next speaker is Christopher McGreavy from Aalto University towards virtual laboratories, AI assistance in experimentation.
So I think you can see my screen right now.
Yeah, we can.
Great. So hi everyone, I'm Chris McGreavy at the University of Aalto, and I'll be presenting some work based on a framework paradigm we have are developing here at Aalto, University of Helsinki and University of Manchester into virtual laboratories. This is in collaboration with Carlos Sevilla-Salcedo, Arto, Klami and Samuel Kaski that are working between these three universities. And what I'm going to talk about today is virtual laboratories in terms of, like, I'm going to introduce what we mean by virtual laboratories, talk about the objective of them, the structure of a software framework we've got to kind of promote and push to apply this virtual laboratory out into the wider community. Some use cases that might be representative of some of the work you're doing and potentially be useful for showing how you can adopt these principles that we're showing, and then give you some information on how you can get involved with the software development as we go along. So when we talk about virtual laboratories, it's very similar to what you'd imagine when you imagine a standard laboratory. So you've got a workbench, you've got your experimental procedure, you've got your instruments to measure anything that you're going to be measuring. You've got dynamic processes that you're trying to uncover or design. You've got methods that are used to process the data, make decisions on what you want to test next. And you've got dynamic processes, you've got user models. So you've got users in terms of, you may have participants in like psychological studies or drug design studies. And you've got user interface, how you interact with your experiment. Do you have to manually change a physical setup from one day to the next, or is it something different to that? So in the virtual laboratories, we're essentially modeling this exact same thing. So you have your data, as you'd have your real world data, we'd have a digital data, and instead of doing manual physical processes, we'd be using simulators. Some very good simulators exist at the moment, and we can leverage the speed and the adaptability of these things in virtual laboratories. We're promoting using AI methods to decide what to study next, how to give you metrics about how well you've performed or designed experiments. And in terms of instruments, whereas you'd have your physical instruments to measure things, we could get information directly from simulators. We could have physical information interacted with these. We could model dynamic processes. We could model user interaction instead of having the expense of having human participants. We could use cognitive models to really speed up the process and simulate humans. And in terms of user interface, we're looking to have a wealth of techniques for you to view your pipeline, to view how the experiment's going, to alter it, to change it up. And one of the big things we're pushing is AI assistance. So when you're conducting a physical experiment, you're kind of limited to having collaborators that are kind of in the room, or maybe you send data to somewhere else. AI assistants we can use to leverage the decision making and the novel learning techniques that we've developed recently into deciding what to do next, how to change processes, how to adapt your experiments to get better results, more representative results and things like that. So that's our idea of virtual laboratories. And in terms of getting people involved, the virtual laboratories, what part of the strength of this is we can use it to standardize and share our experimentation. We can use it to be transparent. We can use it across universities, industry, governance, and within individuals, so everyone can see and be involved in the design, experimentation, analysis, and interaction process, all helped by AI assistance here in the middle. So what this means is we have this lofty, abstract aim. But what this means in terms of physical, like what we're doing to realize this is we're building a software framework such that you can do all these things. So we're modeling the instruments you might use, modeling the cognitive models. We're modeling how you can design the AI assistants. And we're starting kind of small. We have a few virtual laboratories here at Aalto right now, doing a lot of things, and it's very successful in itself. We have, in terms of virtual laboratories here, I mean, we have groups of people that are working towards a similar software goal, and then the next group B here might be working towards a certain set of software that is using like a different set of things. And what we're developing is this workspace, this blue virtual laboratory platform, is to contain everything that these people that these groups need to use the same platform, but have it applicable to their own virtual labs. And gradually, and at the end of the talk, I'll show you how you can get involved, because this is only really successful when it pushes out and gets a lot of people involved. In terms of the framework itself, what we're aiming for is a big part of what we're doing is making it interactive. So we don't want a typical pipeline where you have a few functions and you run a for loop and then you never get any ability to change this. So a big part of what we're doing is pushing AI assistance and monitoring from the experimenter, so you can see what's going on. You can change things. You can alter some parameters. You can change some of the modules. You can change some of the way that the pipeline works. Modularity and generalizability and extensibility are also really big things. So we don't want to make just another narrow pipeline where it's only really applicable to one scenario. We want to make this modular such that, like I showed on the previous slide, multiple sets of people doing different things can use the same pipeline, modify it to their own needs, and have it produce useful results. And easy to use is also a big tenet that we're going for. Is you can produce the best software in the world, you can produce the best paradigm in the world, but if no one wants to use it and it's not easy to use, that's not good for anyone. So we're aiming to make it easy to use. In terms of the structure of this framework, we've got these modules, this modular part on the right here. We can design a framework. You can design like how you want your framework to work. Do you want to pre-process your data? Do you want to use reinforcement learning? Do you want to use supervised learning? How does this involve with your decision making in terms of do you want to use Bayesian processes to decide what to test next? All these kind of things. So this is the kind of things that we're building into this. And in terms of the structure itself, we're using a modular and plugin pipeline. So if you want to do, like I said, if you want to pre-process your data, if you want to do RL, you can drag a module here that says I want to do learning, and then plugins will have plugins for individual supervised learning or RL or anything like that. The same with data processing or decision making. So this is kind of how it's looking, and how we're going to push it into a more modular design, generalizable design. And in terms of use cases, things that might be useful to people, might be useful and useful for guys there is we're looking into, one of the first use cases we're looking into is material design. So on the right here, we're trying to emulate a pipeline that is optimizing the crystalline structure of solar panels for maximum efficiency. We're also working initially on robot co-design, like morphology design and drug design, experimental design, and diagnostic images for hospitals. And one final thing that I'd like to promote is this is not, although it's starting here at Aalto, this is not a Aalto project in terms of it's not meant solely for use in Aalto. It's meant to be used in the wider community. The aim of this project is to be open source, to be useful to anyone sitting in that room that's doing experiments, anyone who's online thinking of doing experiments, running experiments at the minute. This would be used for you, this will be useful for you, and it'll be beneficial for you to be involved in the development going forward. So we're looking to start an open source development community to push this out into the wider world, to make sure it's useful. We don't want to spend all this time developing it when no one's going to be using it. So if anyone around right now wants to get involved, please get in contact, and we can keep you up to date as to what's going on, and we can take into account your needs and how you plan to use this in the future. Thank you very much, and I'll take any questions. Thanks.